Right. Let's look at Algiers this time. Algiers is a 100 pointer this time. So 100 pointer is definitely a step up. There's plenty of new stuff to learn, and if you're bored with stack, here's a chance for you to learn how the heap works, because this is one of the first heap exploitation levels, which is uh, a little tricky to get your head around initially, but once you understand how the heap works and how it's manipulating memory and all of that stuff, it's super fun. So uh, yeah, make a real effort to kind of learn this and do this really well. I mean, even if it takes you a lot of time, stick with it. Don't look at spoilers on the net and stuff like that, and then you'll learn a lot of stuff with this. So without further ado, let's look at the program, and let's like quickly scroll through it. So the first thing you see is the dot strings, which is basically a set of hard-coded strings that you can find in the program. It's a string called heap exhaust robotic. That itself should be a first uh, kind of red light for you to say that this one's a heap level. It isn't a stack. It isn't a stack exploitation level. And then you see malloc, and then you see free later on. Malloc and free basically dynamically allocate memory. So you can say malloc 10, and it would allocate 10 bytes onto the heap and not on the stack. And this functions here. So that again points to it being a heap exploitation. When you do see unlocked root, you see the fake test password valid function, which will not work again. So because this is hard enough as it is, so I wouldn't advise you to go down the test password valid route. And then you see login, and you'll see main somewhere. Main calls login and returns back. So that part stays the same. But let's quickly go through login and have a breakpoint on malloc there. So it'll break on malloc there, right there. So the argument to malloc is 0x10, right? 0x10 is an R15. So quick way to find out what the decimal values. I mean, you can use a calculator and stuff. You just hover your mouse over the register's value. It'll tell you 16 right there. So which is what is actually going to get allocated. And you need to track where it's happening. So the moment you see malloc, you don't know where exactly in the heap or in memory your the program is going to allocate space for you. So if you step right over malloc, because you don't want to know what's inside malloc at this point of time, so you step over malloc and go to the next line, and you scroll over, you see there's this big chunk of memory that got allocated just there, like right here, 0, 0 to 0, 0 here. And so if you've missed that, let's look at it again. So like step, we have another malloc here again, which is for 10, for 16. And you just take a look here. It's 2400 to 2420, and there's nothing after that. So let's step over malloc and see what happens now. You see there's line 2430 added, which means that the program allocated memory like right there. And then let's hit continue, and then it asks you for input. So before doing anything, you just click wait, and let's go back to the program and see what it did. So you have the two mallocs, and then you have the puts, and then you have the puts, and there's the get us in like right there. So let's go see again. So it says enter your username and your password to continue. I mean, at this point of time, let's enter everything. We're just looking at what the program's doing now. So don't worry about the payload. I mean, whatever. Yeah, and you see, not all of it got allocated. I mean, it made some typos while typing. So, but the space allocated by malloc somewhere in memory, and that payload that you entered then got copied here. And then if we hit C again, it'll prompt us to enter the password. So let's enter something different this time. Let's enter, say, 65. Right, and let's like send a huge string in, and there's a lot of stuff that's getting copied like right there, and so you can see that the program, the way it's working, it allocated some amount of memory, and you can already see this like an overflow because you allocated 16 bytes, but you've been able to copy a ton more. So that could be something. So this will sound familiar if you've done a lot of stack exploitation, which you've done up to this point. But will you really be able to smash the stack? You were able to overwrite a lot of stuff. You were allocated 16 bytes. You were able to copy like 1,000 bytes. But will you really be able to reach the return pointer for where login returns to and returns back into main? If you can do that via this and reach whatever the return address is, then it becomes really a stack exploitation problem. It's not a heap exploitation. So I didn't manage to do it, but go ahead, play around with it, and see what happens. See if you can reach return. And if you can, well, great. That's the easy way. That's an easy way to solve the problem. But you get the basics, right? So malloc allocates memory. Your input then goes in there, and it's 16 bytes. So the program's expecting 16 bytes. Anything more than that is going to probably be a problem. And then you hit continue, and you'll notice that it's skipped right off the unlocked door, because test password, while it fail as usual, means whatever you do, it's going to fail, and it'll say the password's not correct, and it's gone into free. Now, at this point of time, right, you definitely want to look at memory. I mean, you looked at memory when you're doing malloc. I will definitely recommend that you look at memory very carefully when you're doing free. And remember, it's the heap, right? It's not the stack. So there may be more than one read and write at a time. Not at a time, but let's say inside a function. So if you step over a function at the end of once a function returns, you might have the same memory like copied to two different places. It's not completely correct, so don't take what I say really literally. But if you have, say, 41 in one location, you might have the same 41 in a different location as well. It's looking at one location, copying it to a different location. So as you're reversing malloc and free, which I would totally recommend this time, it's going to take you a little while to do that, but that's probably the best way to understand how the heap is really working. And the free function, it isn't super huge, it isn't super complex. So take a piece of pen and paper or notepad, or however you work best. Write down the entire assembly program and actually step through it instruction by instruction. This is a good place to actually learn a little bit of basic reversing as well, and see if you entered 4242 as an input, where is that 4242 going, and what instruction is actually causing it to move where it is. And do the same thing for free as well. And so if I step over the free call now, you'll see something changed at the bottom there. And if I step over free again, and that's one instruction that you really want to break at 4538. I don't want to tell you why and all of that stuff, but if you really get stuck while reversing, if you really can't move on, then just set a breakpoint at 4538 and see when it's triggered and why it's triggered, and what kind of data is being manipulated at the point. And if we step over free again, right, and it'll break again, and yeah, and then it returns back. Nothing happened, exited because my payload was wrong, but that's a reasonable hint. I mean, and remember, it's the heap, okay? It's not the stacks. Think of it slightly differently. How does a heap data structure look like? What are its components? What components accessed when and why? Yeah, I really don't want to say much more than that, but algiers is a super fun level. It's one of my first ever heap exploitation levels, and I stuck on this for a super long time. Very frustrating, but when you get it, it's really cool. So stick at it. Might take you a couple of weeks too. I mean, if you're smart, you'll probably get in a couple of hours, but it's fine. You're just learning at this point of time, and yeah, if you get stuck, a good point. It's a good time to kind of mention this is to definitely go onto the IRC channel for microcorruption. A bunch of helpful guys out there. You might not get answers immediately, but it's super nice guys. They helped me a lot when I was learning this stuff. Yeah, or you can just send me an email. I mean, I'll be happy to help you whenever I can, however I can. But have all your basics straight. I'm fairly sure you'll eventually get it. All the very best, and it's only getting harder from now on. Alright, thanks, bye.